Imagine you are standing in a dark, silent space, hundreds of feet beneath a bustling city or a massive mountain range. Above you are millions of tons of rock, soil, and water, all pressing down with a weight that would crush a conventional building in an instant. This is the world of the tunnel, a feat of engineering that requires us to go where humans were never meant to go. To build a tunnel is to engage in a slow, high-stakes wrestling match with the crust of the Earth itself. The first challenge of any tunnel is simply knowing what lies ahead. Before a single shovel hits the dirt, geologists use seismic imaging and deep core drilling to create a map of the underground. But the Earth is full of surprises. You might be carving through solid, predictable granite one day and hit a pocket of pressurized water or running ground, soil that acts like a liquid, the next. In tunnel construction, the greatest fear isn't the rock, it's the unknown. For centuries, tunneling was a brutal, manual process called drill and blast. Workers would drill holes into a rock face, pack them with explosives, blow the face apart, and then clear the rubble. It was incredibly dangerous and painfully slow. While we still use this method for very hard rock in remote areas, the modern era of tunneling belongs to a machine that is often described as a mechanical earthworm. The tunnel boring machine, or TBM. A TBM is a massive, subterranean factory. At the very front is the cutting head, a rotating steel wheel covered in hardened, disc cutters, that can grind through everything from soft clay to the toughest quartz. These machines are enormous, sometimes as wide as a 5-story building and longer than a football field. As the head rotates, it chews into the earth, and the spoils, the excavated dirt, are carried out the back of the machine on a long conveyor belt system. But digging the hole is only half the battle. If you just dig a hole, the earth will immediately try to fill it back in. This is where the TBM shows its true genius. As the machine moves forward, it uses hydraulic jacks to brace itself against the tunnel walls. In its tail section, it has a robotic arm that picks up massive, precast concrete segments and bolts them together to form a perfect, watertight ring. The machine literally builds the tunnel behind it as it crawls forward. It is a continuous cycle of dig, brace, and build. When the ground is too soft or full of water, like when digging under a river, we use a technique called earth pressure balance. The TBM mixes the excavated soil with special foams or polymers to create a thick paste. It keeps this paste under high pressure in a chamber behind the cutting head. This pressure pushes back against the weight of the water and soil outside, preventing the tunnel from collapsing before the concrete rings can be installed. In extreme cases, engineers might even use ground freezing, pumping supercooled brine into the soil to turn a swamp into a solid block of ice just so they can dig through it. But what if you aren't going through a mountain, but under a harbor? For that, we use immersed tubes. Instead of digging under the seabed, we build massive concrete tunnel sections on land, seal the ends, and float them out into the water like giant barges. We then sink them into a pre-dredged trench on the ocean floor, bolt them together underwater, and pump out the water. It's like building a giant Lego set at the bottom of the sea. Safety in a tunnel is a unique engineering discipline. Because a tunnel is a closed system, smoke and heat are far more dangerous than the fire itself. Modern tunnels are equipped with massive ventilation fans that can change the entire volume of air in the tunnel in minutes. They feature cross passages every few hundred feet, leading to a secondary pressurized safety tunnel where people can escape if the main tube is compromised. Logistics is the final piece of the puzzle. Every single thing needed for the construction — power, light, air, water, and thousands of concrete segments — must be fed into the tunnel through a single entrance that might be miles away. It is a linear assembly line where any breakdown at the front can bring the entire multi-billion-dollar project to a screeching halt. Why do we do it? Why go to the trouble of moving mountains and diving under oceans? Because tunnels are the ultimate, hidden, infrastructure. They allow our cities to breathe, moving subways and sewage away from the surface. They turn a 2-hour mountain pass into a 10-minute drive. They connect islands to continents, erasing the boundaries set by geography. The next time you're driving through a tunnel and your radio cuts out, take a moment to look at those concrete walls. Think about the TBM that chewed its way through the dark, the engineers who balanced the weight of the world, and the fact that you are currently standing in a space that nature never intended to exist. It is a triumph of human ingenuity over the crushing weight of the earth. When you enter a long tunnel, do you feel a sense of claustrophobia?